Hello viewers, welcome to the channel Amazing Civil Engineering Studies. In today's video we are going to discuss about what is SBC of soil. The first test to be carried out before construction is the soil's safe bearing capacity. It is a preliminary test that must be carried out before the construction of any structure. It is recommended that the safe bearing capacity of the ground be tested at all points of the foot. What is SBC of soil? The safe bearing capacity of soil field test is performed to verify the soil's ability to support loads. Let's consider an example of a small plastic chair. The small plastic chair made for children and can support a capacity of 10 kilograms. Suppose, if an adult has sat down, the chair will be broken. The same case is applied to the soil. If more load is applied to the soil than its resistance, the soil begins to shift or break, which leads to settlements. In order to keep the structure safe, the safe bearing capacity is calculated on the field at different points, and the foot selection is made accordingly. The maximum load per unit area that the soil can support without any displacement or settlement is referred to as safe soil capacity. Safe bearing capacity. The safe load to be taken on the soil for design purposes is called the safe bearing capacity of the soil. The safe bearing capacity of a soil can be defined as the bearing capacity of a soil divided by a number usually by constant and called safety factors. The safety factor depends on the type of construction and the nature of the soil. Generally, a safety factor of 2to4 is used for different purposes. If the final load of the soil is 6 tons m2 and its safety factors are 3, the work or project loads to be given to this soil will be 6/3 equals 2 tons m2. Soils and their bearing capacity. The soils on which a structure rests can be classified into 3 categories. Hard soils. These soils are generally rocky in nature, incompressible, and can withstand reasonably good loads. Solid rock, murum, and rocky soils are examples. Soft soils. These are alluvial soils and are compressible when loaded. They can carry a lot of loads. Common clay and common soils are examples of this. Spreading soils. These soils are compressible when confined and prevented from spreading. These soils, when loaded, spread laterally. Sand and gravel are examples of this type of soil. Safe bearing capacity values for different soils. The capacity of the soil to allow loads from the foundation is called the bearing capacity of the soil. The gross pressure at the base of the foundation on which the soil fails is called the ultimate bearing capacity. When considering different failure conditions, the ultimate bearing capacity is divided by a certain safety factor, and the resulting one is called the safe bearing capacity of the soil. It is essential to know the bearing capacity of the soil before designing the foundation. It can be determined by different field tests. However, there are standard values for safe bearing capacity available for different types of soils, and these values can be used when test data is limited or rapid construction is required. Values of safe bearing capacity for different soils. The following provides values for the safe bearing capacity of different soil types. S.No. Type of soil. SBC, KN/M2. Rocks. 1. Laminated rocks. Examples are sandstone, limestone, etc. 1620 KN/M2. 2. Hard rocks such as granite trap, diorite, etc. 3240 KN/M2. 3. Residual deposits of broken rock and hard shale, cemented material. 880 KN/M2. 4. Soft rocks. 440 KN/M2. S.No. Type of soil. SBC, KN/M2. Cohesive soils. 1. A wet mix of clay and sand and clay that can be indented by thumb pressure. 150 KN/M2. 2. Black cotton soil. Expansive clay, 50% saturated, in the dry state. 130 to 160 KN/M2. 3. Soft indented clay with moderate thumb pressure. 100 KN/M2. 4. Soft shale, hard or hard clay in a deep bed, dry state. 440 KN/M2. 5. Medium clay easily cut with a miniature. 245 KN/M2. 6. Very soft clay that can be penetrated by tapping a few centimeters. 50 KN/M2. S.No. Type of soil. SBC, KN/M2. Cohesionless soil. 1. The compact mix of gravel, sand and gravel with good resistance to tool penetration. 440 KN/M2. 2. Compact and dry coarse sand. 440 KN/M2. 3. Medium compact dry sand. 245 KN/M2. 4. The mixture of bulk gravel or sand, dry state. 245 KN/M2. 5. Fine sand and silt, composed of dry pieces. 150 KN/M2. 6. Loose and dry fine sand. 100 KN/M2. Methods for determining soil bearing capacity. There are many methods to discover the bearing capacity of soils. A very simple method of determining bearing capacity is as follows. Dig a hole of size 2 meter x 2 meter and the required depth. The bottom of the well is leveled by simply spreading the soil manually. It should never be compacted. On the steel plate, erect a 40 cm x 40 cm wall, with bricks, stone blocks, or concrete. Almost 50 cm above the adjacent ground level. In the center of this well, place a 60 cm x 60 cm x 5 cm steel plate. Head towards the pins equidistant from the steel plate, as shown in the figure. The difference, the levels between the top of the pins and the wall, are noticed by an irregular level. Now, gently place the bearings on top of the wall, building a wooden platform. The cargo may consist of sandbags, beams, or RSJ. The bearings are increased by an adequate amount. Usually 0.5 tons in an interval of 20 to 30 minutes. Before each bearing increases, the difference in levels between the pins and the top of the wall is observed. Note that the level difference will remain constant until the soil gives way. As the difference increases, the bearing increase must be stopped. The bearing capacity of the soil will be the total bearing divided by the area of the steel plate. Thanks for watching. For now, please subscribe, like, share and do not forget to press bell icon.